Hello everybody. In this video tutorial I want to quickly show you how we can determine the order of reactants in a metabolic pathway. So let's assume we have a short metabolic pathway where we have a compound A that is converted by enzyme E1 into compound B, which then is converted by enzyme E2 into compound C, converted by enzyme E3, and this is converted into D, and the final step would be enzyme E4, which converts D into a product P. So that is our pathway, but at the moment we don't know what is the correct order of A, B, C, D that gives us product P. Let's assume that it is the product P that we can easily measure, let's say with a spectrophotometer or something like that. So we can measure the production, the concentration of P. So how can we figure out actually that A, B, C, D is the correct order and not perhaps D, C, A, B or something like that in this pathway? So what we can do is we can take a sort of a cell extract. So here's our cell extract that contains the enzymes required for this pathway, so E1, E2, E3 and E4, they are all in there, so plus enzymes, but it does not contain the metabolites. It does not contain A, B, C, D or the product P. And what we can do now is we can add to this cell extract that we have, we add individually the compounds A, B, C, D, which we suspect will lead to P. So let's start with compound D. What would happen if we add compound D to this cell extract? Well, compound D will be very quickly converted to the product P by the enzyme E4, which is in the cell extract. So we just wait a little bit of time and we will get almost all of D will be converted to P. So we know that D is part of this pathway. Now, what would happen if we use a compound, let's say compound H? Now, H is not part of the pathway. So if we add H to our cell extract, nothing would happen. We would not see an increase in P. So it's not converted into P, and we would not see P increase. So this means H, if we don't see any production of P, it means H is not part of this pathway. If we add D, D is very quickly converted into P and we would get a really high absorbance in the case of P here. Okay, so what would happen if we add compound C? So we wait a little bit. Now C is converted by enzyme E3, it's converted into D, and D then is again converted by enzyme E4 into P. So we add C, we wait a little bit, but because it takes a little bit longer for C to get to P, we would get a little bit less absorbance absorbance in P, just simply because it takes a little bit longer time to go from C to P, because it has to go through this D step. And we can just simply compare the absorbance that we measure in the first case with D and in the second step when we add C, and we find that there is a difference in the absorbance. Now, what would happen if we add instead of C or D, if we add compound B? Well, B would be converted by enzyme E2 to C. This then converted to D, and this eventually to P. Again, we measure P, we wait the same time as we've done for D and C, and we will find that we get even less absorbance of P, because it takes more time for B to get to P than it took for C to get to P and for D to get to P. And in the last step, of course, we just simply add compound A, and you can imagine it takes even longer for A, or if we just simply wait for a small time, like we did for D, C, or B, the concentration of P that we measure will be very low at this point. We need to give it the chance to produce, to go through P, but not all of A will have reached P. So the concentration of P will be fairly low. And with this method, where we just simply supplement the cell extract that contains the enzymes with the components of a metabolic pathway, we can easily figure out what is the order of these individual compounds in this pathway. We just simply look at which compound gives the highest absorbance, because we know the highest absorbance of P, I should say, because we know that this compound must be the closest to P. So in this case, it would be D. And then we just look at the compounds and check out which one has the next highest absorbance. This is then one step removed, so that would be C. And then the next lower, or the next higher absorbance that we get in the product would give us B, and eventually it would be A. So this is a really nice method that we can employ to sort of figure out what the components in a metabolic pathway might look like. This only applies to very simple linear pathways. If we have more complex pathways with branches, then we would need to apply slightly different methods. I hope this makes sense, and thank you very much for watching.